look at some of the content. Hi, welcome to this little walkthrough. We're going to take a look at some of the content from Unit 1. So we'll begin with this question of what is a computer? A computer is something that you would probably think of as like a laptop or a desktop, but really a more accurate and broad definition is anything that helps process information. It's something that helps you with thinking tasks as opposed to just physical labor tasks. So if you'd like to come up with some items of what counts as a computer, not a computer, and some definitions just for your own mental practice, feel free to do that. And then watch this little video here where you get a little bit of background on how computers evolved.
Hi, I'm Nat. I was one of the original designers of the Xbox. I've been working with computers since I was maybe 7 years old, and now I work on virtual reality.
Computers are everywhere. They're in people's pockets, they're in people's cars, people have them on their wrists, they might be in your backpack right now. But what makes a computer a computer?
What does make a computer anyway?
And how does it even work?
As humans, we've always built tools to help us solve problems. Tools like a wheelbarrow, a hammer, or a printing press, or a tractor trailer. All of these inventions helped us with manual work. Over time, people began to wonder if a machine could be designed and built to help us with the thinking work we do, like solving equations or tracking the stars in the sky. Rather than moving or manipulating physical things like dirt and stone, these machines would need to be designed to manipulate information. The earliest computers were made out of wood and metal, with mechanical levers and gears. By the 20th century, though, computers started using electrical components. These early computers were really large and really slow. A computer the size of a room might take hours just to do a basic math problem.
These machines are things of gleaming, vari-colored metal and numerous flashing lights.
Computers started out as basic calculators, which was already really awesome at the time, and they were only manipulating numbers back then. But now we can use them to talk to each other, we can use them to play games, control robots, and do any crazy thing that you could probably imagine. The computers we use today look really different from the earliest thinking machines. And who knows what the computers of tomorrow will be like. My hope is that you get to help decide what you want the computers of tomorrow to look like.
After that, I think that you'll reflect a little bit more and realize that, okay, a computer could even exist without electricity. It could even be mechanical. It's just something that helps process information. After that, we'll move on to a topic of number systems. Now, the number system that humans use most is called the decimal system. And the reason is that humans have 10 fingers, so we're used to counting in groups of 10. That's why we have 10 symbols, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Computers don't have fingers, so they don't have 9 symbols. They use the binary system, and that is composed of just the numbers 0 and 1. And you've probably seen ones and zeros. You know that that's what computers use. If you've seen the Matrix, you've seen that rain of ones and zeros coming down. That's the reason. So now this question here, let's move on to this. So in the decimal system, we have 10 symbols, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And that means if I have one decimal digit, I could count from 0 up to 9. After that, I've run out of possible values, so I have to use another digit. If I get 2, then I can count 9, 10, because I have a 1 and a 0. And I can keep counting up all the way 11, 12, 13, 14, all the way up to 99. So that's as high as I can count with 2 digits. Now this question here, if you can count up to 99 and you include the 0, that means that's 100 possible different values. So if you add another digit now, then you can count up to 999. And if you include the 0, that's 1,000 possible values. So the pattern you can notice there is every time you add another digit, you get 10 times as many possibilities. You go from 10 to 100 to 1,000, 10,000, etc. Now that should be pretty familiar to you. You've been using the decimal system since you were pretty little, probably. The binary system is a little bit different, or significantly different, because binary only has 2 values instead of 10. So quickly we're going to look at how you would count in binary. If I only have one binary digit, how many different combinations can I get? Well, let's take a look. I can put a 0 and I can put a 1. And that's it. If I only have one digit, I only got 2 possibilities. I have just 0 and 1. However, if I have two digits, now I have some more combinations. I could start with 0, 0. I can do 0, 1. I can do 1, 0. And I can do 1, 1. So I've got 4 possible values now. So it went from 2 to 4. Now let's see, what if I have 3 digits? You should first pause this video at this moment and open this slide deck and see if you can figure out how many there are and put them all. Once you've finished trying, you can go ahead and unpause it, and let's take a look at now what they are. So we've got 0, 0, 0, then 0, 0, 1. Okay, now I've run out of options that start with 2 zeros. So now I have to do 0, 1, 0, 0, 1, 1. And now I've run out of options that start with the 0. So now this last 0 has to change to a 1. So I get 1, 0, 0, 1, 0, 1, 1, 1, 0, and the very last one is going to be 1, 1, 1. And that is all the options that I can have with 3 binary digits. So that's 8 combinations. Notice it went from 2 to 4 to 8, and so you might notice there that it's doubling every time I add a new digit, which makes sense. It's a base 2 number system. So to recap that, let's go ahead and watch this little video that explains the exact same thing.
Welcome to this presentation about the language of computers. The first thing to know is that in the most fundamental sense, computers really only understand 2 things, on and off, which in computer language are represented by the numbers 1 and 0. This language, made up of just 1s and 0s, is called binary. To better understand binary, let's take a quick look at the number system we humans use most of the time, the decimal system. The decimal system is a base 10 number system. We use the decimal system because humans have 10 fingers, so it makes sense to us to count in groups of 10. With the decimal system, we count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Once we get to 9, we've run out of numbers, so we have to add another digit. So we make 1, 0 to make 10. Then we get 11, 12, 13, 14, 15, etc., all the way to 99, and then we have to add another digit to make 100. Binary works in a similar way, except since we only have 2 numbers, 0 and 1, we have to use a whole lot more of them. Here's how it works. We start with 0, then 1. Now we've run out of options, so we have to use another digit. We get 1, 0, 1, 1. Now we've run out of possibilities again, so we have to use another digit. 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Now we've run out of options again, so we have to add another digit. We get 1, 0, 0, 0, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 1, 1, 1, 0, 0, 1, 1, 0, 1, 1, 1, 1, 0, 1, 1, 1, 1. You get the idea. And if you don't, it probably doesn't matter. So why are we talking about this at all? Are you ever going to have to convert from binary to decimal or vice versa? Probably not. We're talking about this now so that when we turn to file sizes, everything makes a little bit more sense. Let's take a look at that now.
Once you've finished watching that, now you're ready to take the little number systems quiz. All of the answers to the quiz have been addressed in this slide deck and in the video. Some little reminders. With one binary digit, I have two possible values. With two binary digits, I have four possible values. With three binary digits, I have eight possible values. And as you might imagine, if I get four binary digits, it doubles again to 16 possible values. If I add another one, it would be 32, and so on and so forth. Once you've completed this quiz on number systems, you can proceed to the next section. This is onto digital storage terminology. So we're going to talk about what are these units of storage that you've probably heard about: bits, bytes, kilobytes, megabytes, gigabytes, and how much those can actually store in everyday terms. And these are just some items that you can use to store things. So let's go on to the next slide here. We're going to put these storage terms in order from smallest to largest. So the smallest is a bit. After that comes a byte. There are 8 bits in 1 byte. After that comes a kilobyte, then a megabyte, then a gigabyte, and then a terabyte. So there are 8 bits in a byte. There are 1,000 bytes in a kilobyte, 1,000 kilobytes in a megabyte, 1,000 megabytes in a gigabyte, and 1,000 gigabytes in a terabyte. So some hints you can use to remember that. These are ones students have come up with. So it's the smallest word, and so it's a bit, it's the smallest word, it's the smallest value. It's also just like a little bit, right? Bit stands for binary digit. A bit is one of those actual ones or zero, right? Just a 1 or a 0, that is a bit. Now there's 8 bits in a byte, so this is the second smallest word. And then after that comes a kilobyte. Now the kilo means 1,000. And you can think of some examples of that, like a kilogram or a kilometer, etc. After that, you get a megabyte, which is a million. Now, you could say both start with M, megabyte, million. That's probably the easiest way to remember. After that, you get a gigabyte. A gigabyte is 1 billion bytes. And there are some other words that start with giga. For example, a gigawatt is a million watt, or a billion watts. That's a measure of electricity. And that's one that's a little harder to come up with other hints for. But if we move on to terabyte now, that's a trillion bytes. And tera and trillion start with the number there. And there are some other places you might see that prefix, like a terawatt. I think all the electricity used by humans on Earth is probably measured in terawatts. So in any case, just remember that this is the order that these go in. And now let's actually go on and see how this plays out in practical usage. So here's a little video that you can watch that will recap all of these terms and give you some examples of how much each one of these things can hold, and some different sorts of storage medium that are available for you to put data on and that have been around for a long time and have changed over time. So you can see how we started with floppy disks, moved on to hard drives, and then on to bigger and bigger hard drives and whatnot.
Let's continue our discussion of digital storage terminology. Digital storage uses the binary system, where everything is saved as ones and zeros. The word that's used to describe these ones and zeros is a bit. It's short for binary digit, and it's the smallest unit of data in a computer. These bits, these ones and zeros, are used to store all kinds of information, from text documents to the digital photos that you take to the sounds that come out of your speakers. To store this information, we use a whole bunch of bits put together. The number of bits we have determines how much data we can store. Now for our next term. If you take 8 bits, 8 of these ones and zeros, and you put them together, that's called a byte. It sounds like a mouthful of food, but it's spelled with a Y, and it refers to 8 bits put together. You can think of 1 byte as the amount of space required to store a single letter or symbol in a text document. So if you wrote a paragraph with 500 characters, that would require about 500 bytes of storage space. That brings us to our next term. If you take 1,000 bytes and put them together, that's called a kilobyte, often abbreviated as K uppercase B, or just K. Now I will mention just once that there are actually 1,024 bytes in a kilobyte, and that's because digital storage uses the binary system and everything is expressed in powers of 2. That said, it's okay to just think of a kilobyte as 1,000 bytes, similar to how a kilogram is 1,000 grams or a kilometer is 1,000 meters. 1 kilobyte is enough space to hold about a third of a page of text. Back in the late 1970s and early 1980s, the 5¼ inch floppy disk was a popular storage medium. It could hold 360 kilobytes of information. So now, what's it called when you have 1,000 kilobytes? 1,000 kilobytes is called a megabyte, abbreviated as capital MB. 1 megabyte is enough space to hold about 1 book, 1 photo, or 1 minute of music. Keep in mind, those are approximations and could vary widely based on the quality and type of encoding. The 3½ inch floppy disk, introduced in the 1980s, could hold 1.4 megabytes of data. Now you may be wondering, what's it called when you have 1,000 megabytes? 1,000 megabytes is called a gigabyte, abbreviated as capital GB. A gigabyte is enough space to hold about 1,000 books, or 1,000 photos, or 16 hours of music. By the mid-1990s, a 1 gigabyte hard drive could be purchased for a couple $100s. Nowadays, 1 gigabyte is considered very little storage, and you could get a 1 gigabyte flash drive, SD card, or micro SD card for just a couple dollars if you could find one at all. So now, what's it called when you have 1,000 gigabytes? 1,000 gigabytes is called a terabyte, abbreviated as capital TB. A terabyte is enough space to hold about 1,000,000 books, which is around 80 school libraries, or 1,000,000 photos, or 2 years of continuous music. Nowadays, a terabyte of storage is readily available as a hard drive, solid-state drive, or even SD or micro SD card. So, to recap, we talked about how there are 8 bits in 1 byte, 1,000 bytes in 1 kilobyte, 1,000 kilobytes in 1 megabyte, 1,000 megabytes in 1 gigabyte, and 1,000 gigabytes in 1 terabyte. And that's enough to know for everyday usage. But for those of you who are curious, after terabyte comes petabyte, then exabyte, then zettabyte, then yottabyte. Thanks for watching. I hope you've enjoyed this video and that you have a better understanding of digital storage terminology.
After you're done with that, it's time to get ready for the storage terminology quiz here. So these are the actual questions. We're going to go over the answers to the test. So put the storage items we've learned in order from smallest to largest. So this goes bit, byte, kilobyte, megabyte, gigabyte, terabyte. What is the term used to refer to the individual ones and zeros that a computer uses to store data? That's a bit, and it's short for binary digit, one of those individual ones and zeros. How many bits are in a byte? There are 8. 8 bits in a byte, 8 ones and zeros, which is, if you pay attention to binary from before, that would be 256 possible combinations. And I got to that by doing 2 to the 8. 2, 4, 8, 16, 32, 64, 128, 256. The answers to this is there are 8 bits in 1 byte. How many bytes in a kilobyte? About 1,000. technically 1024, but it doesn't matter too much. All right, kilobytes in a megabyte, also 1000. Remember, each one of these terms, kilobyte, megabyte, gigabyte, is going up by a factor of 1000. And so continuing that, how many megabytes in a gigabyte? 1000. How many gigabytes in a terabyte? 1000. How much space is required to store one character, like one little letter or symbol? The answer is 1 byte, which remember, that's 8 bits. How much space is required to store one image? About 1 megabyte. Now that's a huge approximation because you can have, like, if it was just a little image on a website, it might only take 20 kilobytes, right? Like 1/50th of a megabyte, very small. Or if it's a really high resolution digital camera, you might take an image that's 50 megabytes. But just as a generalization to understand storage, you can think of it as about a megabyte. And the same here goes for music. About 1 minute of music stored as an MP3 or similar format is also about 1 megabyte. It could be more or less depending on the quality. So now let's look at some examples here. If I have 1 gigabyte of storage, how much music, text, or photos can I store? So if you recall from the video, we actually went over exactly the answer. Remember, 1 minute of music takes about 1 megabyte. A photo takes about 1 megabyte. And a book, an average book, takes about 1 megabyte. So there's 1,000 megabytes in a gigabyte. So the answer is really just 1,000. It would be about 1,000 books or 1,000 photos or 1,000 minutes of music. So if I have a terabyte of storage, how much music, text, or videos can I store? Remember, a terabyte is just 1,000 gigabytes. So multiply these by 1,000 and that's your answer. So I'm just going to copy and paste to save time. Just add some zeros. So a terabyte is about 1,000,000 books or 1,000,000 photos or 1,000,000 minutes of music. On to some word problems here. So if I have a PlayStation or an Xbox with a 1 terabyte hard drive, and each game requires 50 gigabytes of storage, how many games can I install before I run out of space? So let's think about it. So we have 1 terabyte is equal to 1,000 gigabytes. So if we take 1,000 gigabytes and divide by 50 gigabytes per game, we get 20 games before we run out of space. Just 1,000 divided by 50. All right, we've got 9 gigs of free space left on our phone, and each photo uses about 1 megabyte. How many more photos can we take before we run out of space? So we just need to do, 9 gigabytes is equal to 9,000 megabytes, so 9,000 photos. That's the answer. On to the next page. So I've got 1 gigabyte of free space on my phone. 1 minute of music takes about 1 megabyte. How many more minutes can I copy before I run out of space? Again, pretty simple here actually. So 1 gigabyte, that's 1,000 megabytes. And if 1 minute of music takes 1 megabyte, it's just 1,000 minutes. On to the next one. I have 600 megabytes of data left on my monthly plan for my phone. How many more hours of streaming music can I listen to before I run out of data? If each minute of streaming music takes about 1 megabyte, and we're talking about hours this time. So let's think. I've got 600 megabytes. So that's equal to 600 minutes that I could stream audio. So if I take 600 minutes divided by 60 to find the hours, we get 10 hours. So I could listen to about 10 hours of music before I use up my 600 megs of data. Okay, if I have 1 gigabyte of data remaining on my monthly plan, and 1 minute of streaming video from YouTube uses 4 megabytes of data, How many more minutes can I watch before I run out? So notice that video uses more, as you might imagine, 4 megs per minute instead of only 1 for audio. So if I have 1 gigabyte, so 1 gigabyte is equal to 1,000 megabytes. I can take 1,000 divided by 4, and that gives me 250 minutes that I can keep watching. And onto the final page here. My iPhone is set to record video at 1080p. We'll talk more about what 1080p means later, at 30 frames a second. And that means that as I record here, every minute of video I'm recording is using 130 megabytes. So when you're recording video on a phone, it uses quite a bit of space. So my phone has 3 gigabytes remaining, and I want to record a video with my friends. How many minutes can I record before I run out of space? So let's start. We'll say 3 gigabytes is equal to 3,000 megabytes. We'll take 3,000, divide that by 130, and we get about 23 minutes. So we can record 23 minutes of video before my phone will be full. Next one. I have an iPhone with 1 gigabyte of free space, and I want to record a voice memo. Now, every minute of voice memo requires about 500 kilobytes. So that's less. Remember, kilobyte is less than a megabyte. So 500 kilobytes is only half a megabyte. How many hours of voice memo can I record before I run out of space? So let's do this math. So 1 gigabyte is equal to 1,000 megabytes. But here I want to know kilobytes actually. So that's equal to 1 million kilobytes. Now I need to take 1 million divided by 500, and I get 2,000 minutes. And if I take 2,000 divided by 60, I get about 33 hours, which on the test might be rounded down to 30 or so choose the closest answer to that. And now finally, to put these media types in the correct order from least space used to most. So the smallest of all of these is definitely text. Text takes up so little space, it's almost just free. After that comes audio. After that comes video. And then finally, what takes the most would be HD video. Hopefully all of that makes sense. Once you've understood that, go ahead on to the quiz on digital storage terminology. If you went through all of these slides with me here, these are literally the answers to the quiz, so you should be just fine on that. And that does it for Unit 1, Parts 1, 2, and 3. Thanks for watching.